Hey guys, Mr. T here. This is another video. This one is on special quadrilaterals. So quadrilaterals are polygons with 4 sides and 4 vertices. There's some specially named quadrilaterals you need to be aware of, and these specially named quadrilaterals have their own special properties to do with their sides and angles. So you'll be solving problems that make use of some of these special properties, so you may as well get familiar with those. What I'll be doing is going through each quadrilateral, what it's named, giving some of their special properties, and then visualizing them on the quadrilateral here. So the first one is a parallelogram. Parallelogram is any quadrilateral where the opposite sides are parallel to each other. So that's a polygon, and this is only one example. There's very many different kinds of parallelograms where the opposite sides are parallel. So to indicate that, this side is opposite to this one, and they must be parallel. The other 2 remaining sides are opposite to each other, and they're parallel to each other too. So opposite sides are parallel. That has been visualized on the parallelogram there. Opposite sides are equal in length. So the opposite sides are parallel. They're also equal in length, indicated by the lines there. So those 2 opposite sides are the same length as each other, and the top and the bottom sides are also the same length as each other, indicated by the double dash. Now, make sure you're aware that the double dash indicates that these sides are a different length to the single dash sides. These double dashes are the same length as each other, not the same length as those. Lastly, diagonals bisect each other. So we've already said that diagonals are a line from vertices, between vertices opposite each other. So that's one diagonal in blue, and the other diagonal there. And diagonals bisect each other indicates that when you've drawn the diagonals, they cut each other in half. That means that this side of the diagonal is the same length, it's been cut in half, as that side, and this diagonal here is going to be cut in half as well. That's going to be the same length as the other section of the diagonal. They're not necessarily the same lengths when bisected as each other. That comes later in a different kind of special quadrilateral. So that's a parallelogram to start off with. Next is a rectangle. So a rectangle is any quadrilateral where all the vertices form 90-degree angles and the 2 pairs of opposite sides are different lengths. So that pairs of opposite sides of different lengths is important because a rectangle is different to a square, where the opposite sides are, the 2 pairs of opposite sides are all the same length. So a rectangle has these special properties. You'll notice that they're very similar to the parallelogram. Opposite sides are parallel. So this side is parallel to the side opposite, and the right side is parallel to the left side, which is opposite to it. Opposite sides are equal in length. So the left and the right sides, which are opposite each other, are the same length as each other. And the top and the bottom are the same length as each other, and they're opposite. And here is where you see the 2 pairs of opposite sides are different lengths. You have pair 1 that go across. They're different length to the second pair, which goes up and down. And that's what makes it a rectangle. The other property is that the angles are all 90 degrees. And once again, the diagonals bisect each other. So if I draw diagonals here, they will bisect each other. But the other special property here is the diagonals are equal in length. So what happens because of this, because that blue line is the same length as that blue line, and because they bisect each other, the halves are all the same length. So unlike the parallelogram where one of these was a double dash, this one they're all going to be the same because the diagonals are all the same length and they bisect each other. The next is a rhombus. So a rhombus is any quadrilateral where all sides are equal in length. Unlike the rectangle, where a pair of them are different lengths, here they're all the same length. It's essentially a rhombus is essentially a square that's been pushed to one side. So opposite sides are parallel again. So left and the right are parallel to each other, and the top and the bottom are parallel to each other. Opposite sides are equal in length, but all sides are equal in length. So even the top and the bottom are equal in length to the left and the right side. The diagonals bisect each other. Opposite sides are equal in length. I might add that all sides are equal. The diagonals bisect each other, so draw the diagonals there. They cut each other in half. Like that. This doesn't necessarily mean that they're the same length though. So all we know is that they bisect each other. The special property here is that the diagonals bisect each other at 90 degrees. So in the middle here, they're going to meet at a point at 90 degrees. So it's 90 degrees all the way around there. And the diagonals also bisect the angles at each vertex. So every vertex here, this is the vertex, this angle formed at the vertex here is cut in half by those diagonals equally. So those angles are the same. And these angles here are the same either side of the diagonal, bisected. So that's the special properties of a rhombus. Two more, we've got a square, and I've already said a rhombus is just a square that's been pushed to the side. A square is any quadrilateral where all the sides are equal length and all the angles are 90 degrees. So the opposite sides are parallel. So the left and the right are parallel to each other, top and the bottom are parallel to each other. Opposite sides are equal in length, but like the rhombus, all sides are equal as well. So they're all going to be one dash. The diagonals bisect each other. Dash dash. But the diagonals here, because all the sides are the same length, diagonals and the angles are 90 degrees, the diagonals are both the same length. So all of those bisections are the same length as well. The diagonals bisect each other at 90 degrees, so in the middle, the angles formed are 90 degrees. The diagonals bisect the angles at each vertex. Now, because the angles at the corners are all right angles as well, and it's the same throughout, these angles are all going to be the same bisection all the way through. So those dots represent the same angle. So that's the special properties of a square. And lastly, a trapezium. You see this one doesn't have many special properties. A trapezium is a quadrilateral where only one pair of opposite sides is parallel, e.g. that top side is parallel to the bottom, but that is all you know about it. The top and the bottom will be different lengths, and because the trapezium is so varied, there's no special properties about diagonals or anything inside or the angles on the outside. So hopefully that helps you out with some of the special quadrilaterals and their properties. You'll be using some of those properties in some problem solving, and I'll see you in the next video.